right, P3, day 2. We're still talking about radicals and rational exponents. So our objectives for this lesson is we're going to add and subtract square roots, we're going to rationalize denominators, we're going to evaluate and perform operations with higher roots, and understand and use rational exponents. So adding and subtracting square roots. It says two or more square roots can be combined using the distributive property provided that they have the same radicand. Such radicals are called like radicals. So what they mean is like both of them have to be a square root if we're adding two radicals, and they have to have the same value underneath it. So like if I had this one here, then we would take and we would add our coefficients. So 1 plus 1 is 2, and we keep the radical the same. And so it's like adding with variables. You can add the variables as long as they're exactly the same. Well, the same thing here. You can add the radicals as long as they're exactly the same, and you only add the coefficients. Excuse me. So example 1 here. So we're going to solve. So notice on A that both of these have a square root of 13, which means they're like radicals, so we can add the coefficients. So we're going to add 8 plus 9, which is 17, and we keep that square root of 13. And the same thing there on B. We have the square root of 17x minus 20 square root of 17x. Remember, there's a 1 here. Our radicals are the same, so we can subtract them. And so we say 1 minus 20 is negative 19, and then we keep our radical the same. Make sure the radical goes all the way over the x there. Now, rationalizing denominators. It says the process of rewriting a radical expression as an equivalent expression in which a denominator no longer contains a radical is called rationalizing the denominator. So when we have a fraction, guys, you can't have a radical on bottom, so you've got to get rid of it. You've got to move it from the bottom to the top, and so in order to do that, it's called rationalizing the denominator. So if the denominator consists of the square root of a natural number that is not a perfect square, we're going to multiply the numerator and the denominator by the smallest number that produces the square root of a perfect square in the denominator. So we're going to make sure that if we're doing the square root that we have 2 of a kind. If we're doing a cube root, which we'll talk about later, then we'd have to have 3 of a kind there. So we're going to make sure we have the number that we need so that we can actually take the square root of it. But what if it's not just a radical in the bottom? What if there's a sum and difference that has a radical involved in it? So radical expressions that involve the sum and difference of the same two terms are called conjugates. Thus, a square root of a plus the square root of b and square root of a minus the square root of b are conjugates. Notice for conjugates, the pieces are the same. The terms are the same. We have square root of a, square root of b, square root of a, square root of b. But the sign in the middle is different. That's what makes it a conjugate. If the denominator contains two terms with one or more square roots, we're going to have to multiply the numerator and the denominator by the conjugate of the denominator. So we're going to have to multiply the denominator by its conjugate, and just remember what we always do to the bottom of a fraction, we have to do to the top. So look at example 2 here. It says we're going to rationalize the denominator. If we look at A, we have 5 over the square root of 3. Well, the square root of 3 I can't simplify, and notice there's no plus or minus sign. So I'm going to have to multiply the denominator by something. Well, remember, for a square root, we need 2 3s to be able to take the square root of it. So we're just going to multiply by another square root of 3. And what we do to the bottom, we do to the top. This here should have the same exact thing on top and bottom. If not, we've made a mistake. So remember, when you multiply fractions, you're going to go straight across. So in the numerator, we got 5 times the square root of 3. Over the denominator, we got the square root of 3 times 3, which is 9. And so we get 5 square root of 3 over, and we actually take the square root of 9, which is 3. The only other thing we need to check is, do the numbers outside the radical reduce? 5 over 3 do not reduce. So therefore, this is our solution. Now B is different. Notice B in the denominator has that plus sign. So we can't just multiply by another square root of 5. This is the one where we're going to have to use that conjugate. And so remember, the conjugate means it's going to have the same pieces. It's going to have a 4. It's going to have a square root of 5, but the sign in the middle is different. So that's a plus. So my conjugate my conjugate is going to have a minus. What you do to the bottom, you do to the top. So we're going to multiply the top by it as well. Remember, that has to have the same thing on top and bottom. All right, so when we do this, in the numerator, we got 8 times 4 minus the square root of 5. And in the denominator, we got 4 plus the square root of 5 times 4 minus the square root of 5. So in our numerator here, we're going to distribute this 8. And so I'm going to write out what I'm going to do here. So I'm going to take 8 times 4 plus, then it's 8 times a negative square root of 5. Now I'm going to come back and do my denominator in a minute. I'm going to just go ahead and work this out. So then we have 8 times 4, which is 32. And I've got 8 times the negative square root of 5. Well, positive times a negative is negative. The 8's outside the radical and the 5 is inside the radical. So we don't actually multiply them. So I have an 8 on the outside and a 5 inside. Now for that denominator, let's go back and do it because I can't do anything else to the numerator right now. So for the denominator here, we're going to do FOIL, which is just distributing. We're going to take that 4 times both of those, and we're going to take the square root of 5 times both of those as well. But I'm going to do it one at a time. So first thing we're going to do is first, so 4 times 4, I'm going to write it out, plus outside, so 4 times the negative square root of 5, plus inside, so the square root of 5 times 4, plus, and then the last, the square root of 5 times a negative square root of 5. And then we just multiply this through. So we got 4 times 4, which is 16. 4 times negative square root of 5, well, positive times a negative is negative. We got 4 on the outside and a 5 on the inside. Then we get square root of 5 times 4. Positive times a positive is positive. 4 on the outside, 5 on the inside. And then our last, we got the positive square root of 5 times a negative square root of 5. Positive times a negative is negative. Square root, both the 5's are inside, so multiply them. 5 times 5 is 25. And now we just need to simplify that denominator. So the numerator is just going to come with us. So we get 32 minus 8 square root of 5 over, we get 16. These are like terms. They both have that square root of 5. And negative 4 plus 4 is 0, so they cancel. So then we have minus, and the square root of 25 is 5. So all I have left is combine like terms on bottom. So 32 minus 8 square root of 5 over 16 minus 5 is 11. The only other thing we might be able to do is you check all your numbers outside of the radical. Is 32, 8, and 11 all divisible by some number? They are not. So therefore, this is our solution.